This tutorial is designed to accompany Appendix D using Excel to solve enzyme kinetics problems. I've constructed a Lineweaver-Burke plot, and I've determined that the type of inhibition is competitive. So now that we know the type of inhibition and we have the slope and the y-intercept data, it is possible to calculate Km and Vmax in the presence and in the absence of the inhibitor. Since this is competitive inhibition, the values of Km with and without the inhibitor will be different, but the values of Vmax with and without the inhibitor will be the same. So let's use the line S data that we calculated to determine the values of Vmax and Km. So over here, I have the column of data for the kinetic data without the inhibitor. So Vmax is just simply the inverse of the y-intercept. So I type equals 1 divided by, and here's the y-intercept right here, and that's the value of the Vmax. I can decrease the number of significant figures to 3. It will be easier to calculate the Km if I know the value of the x-intercept, and I can calculate that using the line S data as well. So that is equals minus the y-intercept divided by the slope. So that's the value of the y-intercept. Now it will be easy to calculate Km simply by taking the negative, so it equals minus 1 divided by the x-intercept. And then that's the value of my Km. I'll do the same thing over here with the line S data with the inhibitor. Again, here the Vmax with the inhibitor is the same, but I'll still use the intercept, the y-intercept determined with inhibitor data. So equals 1 divided by the y-intercept, and let's set the number of significant figures to 3. Again, the x-intercept is calculated by taking minus the y-intercept divided by the slope. And the Km then is simply the negative of the reciprocal of the x-intercept. And again, I will set the number of significance figures to 3. So we can see that our values of Vmax with and without the inhibitor are, within experimental error, the same, but the values of Km and Km apparent are quite different.